After conducting the normality tests, the next step is conducting the hypothesis tests. And when conducting the hypothesis test, we're also going to conduct the correlation analysis. So we come to analyze, then go to the descriptive statistics and move to crosstabs. And we are going to use rows and columns. The columns will have the y variable or the dependent variables. What is the divorce status? We're going to check this as the dependent variable, while the rest are going to be used as the rows or the independent variables. Checking if we have to use exact, this is okay. Don't have to change anything. Checking the statistics, we are going to use the chi-square. We are also going to check for the correlations, and it is also important to check for the phi and Kramers V. The correlation analysis is best conducted using either Pearson or Spearman rank correlation. However, the phi and Kramers V are important also in checking the correlation for the discrete data, and that is why I always use, or I love to use it to check the correlation analysis for the discrete data. So I have to click, because since most of our variables are not continuous data sets, the results of the correlation analysis may be misleading. So sometimes I use the phi and Kramers V so that I can just compare whether we are consistent or not consistent. Then I click OK, continue. The rest is alright, you don't have to change anything. Then I click OK. For the first research question, we are going to determine, is there an association between the duration the husband has received higher education and the divorce status? In the second research question, we are going to assess, is there an association between the husband being black and the divorce status? In the third research question, we are going to assess, is there a relationship between the husband or the couples having mixed ethnicity and the divorce status? Therefore, our first research question, we have the summary, and this summary gives us the frequency analysis and the percentages. Less than 12 years, we have 393, and their divorce status who are less than 12 years. The divorces who are censored is 895. 12 to 15 years, those that are divorced are 529, while those that are censored are 1126, and such and such. Therefore, this is going to give us the relationship between the divorce, the husband receiving higher education, and the divorce status. Therefore, the chi-square value is 6.289, while the asymptotic significance or the p-value is 0.043. Our key value that we are going to assess is this value, this asymptotic significance value. The chi-square value is important, but since we are assessing at 95% confidence interval or a 5% level of confidence, this value is what we are going to check. It is critical. If this value is less than 5% or less than 0.05, there is a significant association between the husband receiving higher education and the divorce status. There's a significant association between the husband receiving higher education and the divorce status. Therefore, we are going to assess the correlation so that we understand, well, how does or to what degree does higher education affect the divorce status. We check these symmetric measurements and check for the Spearman rank correlation. Since all the data sets we did conduct normality tests, and we found that they are not normally distributed. The outcome was not normally distributed. Therefore, we're going to use the Spearman rank correlation. And the Spearman rank correlation indicates that there is a very, very low correlation because this value is 0.015. A high correlation is indicated by values that are higher than 0.7, and the best correlation values are indicated for values that are higher than correlation values that are higher than 0.9. However, checking this, we find that the Spearman rank correlation is 0.015. This is a positive value indicating that the higher the husband receives, the lower the divorce status. However, this value is too low. It is insignificant. Checking the phi value, it is also very low. The Kramer's value is also very low. Therefore, we can say, or we can confidently say that yes, there is an association between higher education and divorce status. However, the correlation or the association is very low. We check also if the ethnicity of the husband affects the divorce status. So we go directly to the asymptotic significance value, which is 0.862. We find that this value is higher than 0.05, indicating that there is no association between the ethnicity of the husband and the divorce status. Therefore, there is no association between the ethnicity of the husband and the divorce status because the p-value is higher than the alpha value. So this is higher than 0.05, indicating that there is no association between the divorce status and the ethnicity of the husband. However, we might need to check also the correlation, and we find that the correlation values are all 0.0003, and this is too small a value. Let's say it is insignificant. There is no correlation between the husband being black and the divorce status. This is 0.3%, which is very low, very insignificant. Now, the next research question is to assess, is there an association between the couples being of mixed ethnicity and the divorce status? Going directly to the chi-square test, we find that there is a significant association between the ethnicity of the couples, or whether the couples have mixed ethnicities, and the divorce status. There's a significant association between these two variables. Now, the next is to check the correlation. We find that these are also a very small correlation. The correlation is positive, but also it is also very low. These correlation values, all of them are just too low or insignificant because they are values that are lower than 70%. Therefore, okay, there is an association as indicated by the hypothesis tests. However, the correlations are very low, indicated by the phi value, the Kramer's value, the Pearson R value, and the Spearman rank correlation. All these values indicate that the correlations are very low, and though the hypothesis indicates that there is an association, the correlations are very low. So we'll find that what we were analyzing was analyzing the crosstabs is majorly used for analyzing the discrete variables. Therefore, when we conducted the analysis for years in marriage, which is a continuous variable, the SPSS output did not give us the required value. So to determine how the years in marriage affect divorce, we're going to use the ANOVA. We're going to use the analysis of variances. So we're going to do linear regression so that we find if there is any relationship between the number of years in marriage and the divorce status. So the dependent variable is the divorce status, and the independent variable is the years in marriage. The statistics we are going to conduct are model fit and the estimates at a 95% confidence interval. Continue the plots if we have to plot any. For now, I don't have to plot any. So I'm going to click OK and wait for the SPSS to conduct the analysis. Therefore, we tested the years in marriage, while the dependent variable was the divorce status, as indicated in this table. So the R square value is 0.116, indicating that this is 11.6%. Therefore, the number of years in marriage explains the divorce status by 11.6%. The number of years in marriage explains the divorce status by 11.6%. So the ANOVA conducts the regression analysis, and this gives us the summary of the ANOVA. What we are interested in are the coefficients in the ANOVA. So the constant value is 1.5, while the years in marriage, what we need here most is this unstandardized beta values. The constant is 1.5, while the unstandardized beta value is 0.011. And also, we also need to check the sig value, the significant value. So the sig value indicates that the values are 0.000, indicating that they are lower than 5%. They are lower than 0.05. Therefore, there is a significant association between the years in marriage and the divorce status. There's a significant association between the years in marriage and the divorce status. However, checking the unstandardized B value, which gives us the correlation, the R square gives us the correlation value as 11.6%, and checking the unstandardized beta value that gives us the beta of this, or the slope of the linear correlation, as 0.001, indicating that also the correlation is low. Therefore, this one is always converted to an equation such as this. Let me insert the equation, insert equation such that it is y is equals to mx plus c, where y is the dependent variable, m is the slope or the standardized beta, x is the independent variable, while c is the dependent variable. No, so c is the intercept. Therefore, in this case, let's check, for example, the output of the analysis. This is the output of the analysis, and this, let me minimize this. So as I minimize this, you'll note that y, which is the divorce status, equals the m is 0.011. So coming this, I type it here, 0.011. X is the independent variable, which is years in marriage. Then I add to c. C is 1.5 for the intercept, 1.5. So this gives us the relation between the years in marriage and the divorce status.